What if your skin could feel more than just touch? What if your clothing could silently listen, not to your words, but to your body, your heartbeat, your brain signals, your stress, your intentions? And what if all of that could be created, not with bulky machines, not with chemicals, but with light itself? We are standing at the edge of a transformation, a place where biology and electronics no longer sit side by side, but begin to merge, where circuits are no longer rigid, cold, and distant, but soft, flexible, almost alive. And it begins with something deceptively simple: printing electrodes directly onto skin and fabric using light. The problem with traditional electronics: for decades, electronics have followed one rule: rigid materials, hard surfaces, precise manufacturing, silicon chips, metal wiring, chemical processing. Powerful? Yes. Adaptable? Not really, because the human body isn't rigid. It stretches, it sweats, it moves unpredictably. Try attaching a traditional electrode to skin and you face a challenge. It peels off, it loses signal quality, it causes irritation. It requires gels or adhesives. And when measuring something as delicate as brain activity, even the smallest disruption can distort the truth. So the question becomes, what if electronics could behave more like skin? Enter conductive plastics. Not all plastics are insulators. Some can carry electricity. These are known as conductive polymers, materials that blur the line between plastic and metal. They are flexible, lightweight, stretchable, biocompatible, and most importantly, they can form the foundation of electronics that move with the body instead of against it. But there's a catch. Traditionally, shaping these materials into functional circuits requires chemical baths, heat treatments, complex fabrication steps. Not exactly something you want applied directly to human skin or clothing. So researchers asked a radical question: what if we could build these circuits without chemicals, printing with light instead of chemicals? Imagine this: no toxic solutions, no harsh processing, no heavy machinery, just light, using carefully tuned visible light. Scientists discover a way to trigger polymerization, a process where small molecules link together into long conductive chains. But here's the breakthrough. This polymerization happens only where the light touches. Think about what that means. Light becomes a tool for drawing electronics. Where you shine it, material forms. Where you don't, nothing happens. No masks, no etching, no waste. Just precision at the speed of light, patterning electrodes directly on skin. Now imagine shining that light onto skin, or fabric, or flexible surfaces. Instantly, you can pattern electrodes directly onto the body, not attached, not glued, but formed in place. These electrodes are ultra-thin, conformable, nearly invisible, highly sensitive. They move with every stretch and fold of the skin. They don't fight the body, they become part of it. And that changes everything. A new era of brain signal recording. One of the most exciting applications, recording brain activity. Traditional EEG systems rely on electrodes placed on the scalp. They often require conductive gels, careful placement, stable positioning. Even then, signals can degrade. But light-printed electrodes offer something new, a direct, intimate interface with the skin. No gels, no bulky hardware, just seamless contact. This leads to higher signal fidelity, reduced noise, greater comfort, longer-term monitoring. Imagine wearing a lightweight cap, or even just printed patches that continuously capture your brain activity with unprecedented clarity. And then ask yourself, what could we do with that level of insight beyond measurement toward interaction? This isn't just about reading signals. It's about interaction. When sensors become invisible, effortless, integrated, they stop feeling like tools and start feeling like extensions of ourselves. Clothing could monitor fatigue, hydration, emotional stress. Skin-mounted sensors could detect disease early, track neurological conditions, enable real-time health feedback, and brain interfaces could move beyond hospitals, into everyday life. The role of conductive polymers in the future. Conductive plastics are not just enabling this shift, they are driving it because they solve a fundamental problem. How do you build electronics that belong on the human body? Not beside it, not attached to it, but part of it. Their properties make possible wearable computing, smart textiles, bio-integrated sensors, flexible neural interfaces, and when combined with light-based fabrication, they unlock something even bigger, on-demand electronics, a world where circuits are drawn, not built. Imagine a future where you don't manufacture electronics in factories. You create them wherever you are. Need a sensor? Shine a light. Need a circuit? Draw it. Need a medical interface? Print it directly onto the patient. No supply chains. No delays. Just instant functionality. But what are the limits? Every breakthrough raises new questions. How durable are these light-printed electrodes? Can they withstand sweat, friction, daily wear? How scalable is this technology? Can it integrate with existing electronic systems? And perhaps most importantly, where do we draw the line between human and machine? Because when sensors disappear into skin, when clothing becomes intelligent, when brain signals are continuously recorded, we are no longer just using technology. We are merging with it, the bigger picture. This is not just a materials breakthrough. It's a philosophical shift from rigid, flexible, external, integrated, mechanical, organic. Light, something we've always associated with vision, is now becoming a tool for creation, not just illuminating the world, but building it, closing thought. So the next time light touches your skin, ask yourself, what if it could do more than warm you? What if it could write technology into your body? What if your clothes could listen, your skin could sense, and your mind could connect without ever touching a device? Because the future of electronics may not be something you hold. It may be something you wear, or something you are,